All right, let's take a look at our warm-up for today. Question number 1, 5 to the third power. 5 to the third power means what? 5 times 5 times 5. 5 times 5 times 5. And 5 times 5 is 25. And then 25 times 5. If you don't know that, do the standard algorithm. 2 times 5 is 10. No, it's not 25 times 2. Wake up, Mrs. Miller. 25 times 5. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. So the answer to number 1 is 125. All right, number 2. We still seem to be struggling a little bit with these order of operations. 8 plus 12 divided by 3 times 5 plus 2 to the 4th power. So where do we start? We start with parentheses. We have both division and multiplication. So we need to work left to right. 12 divided by 3 is 4. And 4 times 5 plus 2 to the 4th power. Now what? Still inside the parentheses, 4 times 5 is 20. 8 plus 20 plus 2 to the 4th power. Now I have addition, addition, and exponent. What's next? Exponents. What does this mean? 2 times 2 times 2 times 2. And 2 times 2 is 4. And 4 times 2 is 8. And 8 times 2 is 16. So now we're going to rewrite 8 plus 20 plus 16. And now we just have addition, so we work left to right. 8 plus 20 is 28. And 28 plus 16 . 44. So your answer for number 2 is 44. I should see all of these steps. This is the way you learned it. You may have learned like showing it differently last year, but you rewrite each step. There's some of you, when I'm glancing around the room at your papers, you're not showing each step. You've got to show each step. All right, number 3. 4 squared plus 3 times 2 plus 8x. All right, order of operations say do what's in the parentheses first. Is there anything we can do in the parentheses? Can I add 2 to 8x's? No, they're different things. Parentheses is done. Then what? Exponents. What's 4 squared? 16. 16 plus, now I have 3 times 2 plus 8x. Now I have multiplying left. That means 3 times everything in the parentheses. So what property do we need to do? Are we not recording? It shows recording right here, and then it shows something weird is happening. All right, well, we're just going to give it our best. Let's see. Let's pause. Something weird's happening. Okay, so what property is this? When I multiply this 3 times everything inside of there, I need to do the distributive property. So then it's 16 plus 3 times 2 is 6 plus 3 times 8x is 24. X. And now what can I combine? 16 plus 6 is 22. 22 plus 24x. x. 22 plus 24x. Any questions on that one? All right. And the last one, number 4. And remember I said change that to an addition problem. So 2 to the third power plus 7 squared. 2 to the third power means 2 times 2 times 2. 2 times 2 is 4. And 4 times 2 is 8. 8 plus, and what's 7 squared? 49. 8 plus 49, 57. Your answer to number 4 is 57. All right, questions on the warm-up? No? Okay. All right, let's put the warm-up to the side. Let's just talk about the warm-up for tomorrow. These are dividing fractions. I noticed on some of your warm-up quizzes you were turning them to decimals and then doing the division. That normally would be okay, except I'm specifically checking to see if you can divide fractions. This is going to be the part on Georgia Milestones where they're going to check to see if you can divide fractions. You cannot turn them to decimals and have a decimal answer. They're looking for a fraction answer. So if you're going to turn them to decimals, you have to then be able to turn your answer from a decimal back to a fraction. You know how to do that. So if you turned them to decimals and you gave me a decimal answer on your warm-up, it was wrong. Because they're specifically looking to see if you can divide fractions. That's the standard, being able to divide fractions. All right, so we started talking about inequalities last week in your inequality lab that you were finishing up today. So let's look at the notes for today. All right, so you all know that this symbol means less than. So an example is 3 is less than 5. This symbol means greater than. 10 is greater than 7. What's this mean with the little line under it? Less than or equal to. Less than or equal to. So 3 is less than or equal to 9. There's lots of different choices, but how is this different than this? Could 5 be less than 5? If I change that, could 5 be less than 5? No, but could 5 be less than or equal to 5? Yes, it just gives you a different option. So 9 does fit here. 9 is less than or equal to 9. Without that line, 9 could not be less than 9. So you have to make sure that you are interpreting correctly. All right. Greater than or equal to. 4 is greater than or equal to 1. This symbol right here means not equal to. Not equal to. All right, any questions about what those symbols mean? All right, so for each statement, write the corresponding inequality. So here we need to change words into a math problem. 7 is less than or equal to 23. So what does that look like? It looks like this. 7 is less than or equal to 23. You need to be able to take words and change it to an inequality. 56 is greater than 28. That looks like this. 56 is greater than 28. Two is not equal to 5. 2 is not equal to 5. 7 6/10 is less than 8 2/10. 7 6/10 is less than 8 2/10. And the last one, 5 3/4 is greater than 4 2/3. 5 3/4 is greater than 4 2/3. All right, are there any questions about how to take these words and write an inequality statement? Okay, now we're going to take this statement and turn it into words. What would I say for this one? How would I read that? 7 8/10, Andrew? Yes, 7 8/10 is not equal to 23 7/10. 7 8/10 is not equal to 23 7/10. All right? How am I going to read that one? What are the words going to be? Hello? Words. What am I writing? Brianna? Yes, 8 1/4 is less than or equal to 8 7/10. 8 1/4 is less than or equal to 8 7/10. Last one. What are we going to say about that one, Maddox? Yes, 3/4 is greater than or equal to 75/100. And actually, those are exactly equal because those, if I change that to a decimal, I get 75/100. So, but we can say 3/4 is greater than or equal to 75/100. All right, now we're going to use the greater than or less than sign to make each statement true. 12 is, what sign goes in here? Greater than 2. Greater than is that way. Remember, you probably learned in elementary school the alligator wants to eat the bigger number. 12 is greater than 2. All right, let's think about this. 1 2/10, is that greater than or less than 1 201 thousandths? So I think we need to add some zeros. 1.200, 1.201. Which one's bigger? This one is bigger. This one, people thinks that you think it looks different, but you've got to add 2 zeros. And so this is less than. 2 1/10 is less than, 1 2/10 is less than 1 201 thousandths. All right? How can I compare these? So let's change 1/3 to a decimal. 1 divided by 3, and I get 3 repeating. 3 and 3 repeating. Now this one's kind of tricky. What's the next number in this one? A 0. What's the next number in this one if that 3 repeats? 3. So although they look the same, are they the same? No, not when you look at the hundredths place. So this one is greater than. All right. 10 and 25/100, 10 and 1/5. How am I going to compare those? They're fractions and decimals. What's the easiest way? Let's turn this into a decimal. How do I change 1/5 to a decimal? 1 divided by 5. So this one is 10 and 25/100. And then 1 divided by 5 gives me 2/10. 10 and 2/10. So what's this next place so that I can compare? A 0. So this one is greater than this one. $10.25 is greater than $10.20. Does that make sense? So if you're trying to compare fractions and decimals, turn the fraction into a decimal, and then make sure that you're comparing all the way out to the same place. All right, so let's use the less than equal to, greater than equal to compare these two things. One is less than or equal to 2. 4 2/10. 4 1/4. So 4 2/10 looks like this. 4 1/4. Anybody know what 1/4 is as a decimal? What's 1/4 of a dollar? 25 cents. So what digit needs to go after this? A 0. So 4 2/10 or 20/100 is less than or equal to 4 1/4, which is 4 25/100. All right. 1/3 and 3/10. Well, that's going to be like up here. 1/3 is 3 repeating. 3/10 looks like this. So I've got to go out to the next digit to be able to compare. What's the next digit if this is 3 repeating? 3. And this next digit is a 0. So this is greater than equal to. All right, now this one's going to trip a lot of people up. 25/100 and 2/5. Why do you think a lot of people think those are going to be the same? Because that's a 2 and a 5, and that's a 2 and a 5. But is this 25/100? No. How do I turn that to a decimal? 2 divided by 5. 2 divided by 5, and you get 4/10. So this is 4/10 or 40/100, and this is 25/100. So this one is less than or equal to. This little cross thingy right here is driving me crazy. I don't know why it's there today. All right, let's look at this last one. 24, or this last row, 24 and 33/100, 24 and 1/3. So 24 and 33/100, 24 and 3 repeating. So what's this next digit on this one? A 3. I still don't have enough information to compare. What's the next digit on this one? A 3. What's the next digit on this one? A 0. Now can I compare? Yes, this one, 330 is less than 333. So less than or equal to. Does that one make sense? You can keep going on a repeating decimal until you get to a place to where the place value is different. All right. 18/100 and 1/8. Are those the same? Is 18/100 and 1/8 the same? I need to do what here? Divide. 1 divided by 8. 1 divided by 8, and I get 125,000. So 18/100. 1, 2, 5. All right, can I compare them like that and say 125 is bigger than 18? No, what do I have to put here? I have to put a 0. That's 180 thousandths, 125 thousandths. Which one's bigger? This one's bigger. Greater than or equal to. All right. Does that make sense to you all? Yes. Okay. All right. So we're going to put it in our journal. You're going to have to cut this page down a little bit to make it fit. And it's going to take up probably the whole page, top to bottom. Let's see what page it's going on in our journal. It's different from last year's journal. It should be on page 105. Is that where we're at? 105. So if you cut it down enough, it should fit on your page. So it should look like that on page 105, and make sure you go up and add that to your table of content. Inequalities on page 105. And we're going to look at the guided practice on page 536. When you're done, get out page 536. Borrow one from a desk near you. $536. Also make sure that those 2 graded papers I gave back to you, you have 5 days to turn those in for corrections. So that's next, let's see, let's have those in by next Tuesday. There are correction papers in the back of the room if you need to make corrections. All right. Those 2 papers I gave back today. Last week's warm-up and the mid-chapter check. You can do corrections on those. All right. Everybody done with this? Yes? Okay. All right, let's look at page 536. $536. All right, determine which number is a solution of the inequality. So this is saying 9 plus a number is less than 17. 9 plus a number is less than 17. And here's our answer choices. Is it 7, 8, or 9? Is 9 plus 7 less than 17? 9 plus 8, or 9 plus 9? Which one is less than 17? What do you think our solution would be for number 1? Is there more than one answer, or is there just one answer? What do you think? Well, 9 plus 7 is what? That equals 16. So is that less than 17? Yes, so 7 is an answer. What about 9 plus 8? What is 9 plus 8? That equals 17. So is that less than 17? No, can't be that one, because that would be equal to 17. And then 9 plus 9 is what? 18. And is 18 less than 17? No, so the only one that's a solution is 7. Do you see what they were looking for there? They were giving you a set, and they wanted you to determine which of the set could be a solution. All right, so this one says b minus 10 is going to be greater than 5. A number minus 10, and this over here has to be greater than 5 when we do the math. So 14 minus 10. What is 14 minus 10? 4. Is that greater than 5? Is 4 greater than 5? No, that one cannot be our solution. Now change B to 15. 15 minus 10, what is that? 5. And so would 5 be greater than 5? Nope, that's not it. Last one. 16 minus 10 is 6. And is 6 greater than 5? Yes, so that one is the only one that is a solution to that inequality. Now, could there be more than that? Yeah, anything bigger than 16 would work, right? Because 17 would work. 17 minus 10 is 7, and that's greater than 5. Would 18 work? Yeah, because 18 minus 10 is 8, and 8's greater than 5. So there are lots more answers, but in this set, 16 is the only one. We need to have a 16 there. 16 is the only answer. All right. Is the given value a solution of the inequality? So they're saying x minus 5 is less than 5. And they want to know if x could be 15. Could x be 15? So rewrite it using substitution. 15 minus 5 is less than 5. What is 15 minus 5? 10. Is 10 less than 5? No. No. So your answer is no. 10 is not less than 5. All right, so do you see what we did? We used substitution, just like we did earlier in our algebra unit. If x equals 15, is this a true statement? So 32 is greater than or equal to 8 times n. So let's use substitution. 32 is greater than or equal to 8 times 3. So is 32 greater than or equal to 24? Is 32 greater than or equal to 24? Yes. So yes, it is a solution. Make sure that you didn't think that meant 83 when you put the 3 next to the 8. Whenever you have a coefficient with a variable, that's a multiplication problem. Number 5. If the bakery sells more than 45 bagels in a day, they make a profit. Do you know what a profit is? Do y'all know what a profit is when a business makes a profit? That means after they've paid all their bills, they've made extra money. Profit is a good thing, okay? So you want to make a profit and not a loss. If a bakery sells more than 45 bagels in a day, they make a profit. Use the inequality bagels greater than 45 to determine which days the bakery makes a profit. So, bagels have to be more than 45. So, did they make a profit on Monday? If the bagels were 18, did they make a profit on Monday? No. Did they make a profit on Tuesday? No. Did they make a profit on Wednesday? Thursday? Friday? Yes, so Friday. Saturday? And Sunday. Okay, so the only days they made a profit were Friday and Saturday. So I'm going to change that to a statement. Friday and Saturday were the only days they made a profit. All right, any questions on what we're doing here? No? Okay, so we'll look at the independent practice as soon as everyone finishes writing that part down. All right, so we're just going to start kind of easy with our inequalities, and we'll work up to graphing. Independent practice problems, page 537, problems 1 through 7. Page 538, problems 8, 9, 10, and 13. It looks like you get to skip 11 and 12. Skip 11 and 12, and you can go ahead and get started. If you have a question, come see me.